Hello, everyone. It's nice to meet all of you and meet all the Keycloak community. Some people I've been following for years now, and it's a good thing to meet them in person. And this talk is about the 5 deadly sins when using Keycloak or OAuth in general for SSO. The title might seem a bit dramatic, but I think that's what got me here. So let's do it. Um, I'm going to share with you my experience with OAuth. So my first very OAuth experience was 10 years ago. And I just joined a consulting firm. And one of my very first assignment was to assess a mobile application that used OAuth implicit flow. It was a bit intimidating, but also exciting. And since back in these days, the adoption of OAuth was not that common, and it's quite rare to notice or came across an application that used OAuth. But at the end, we managed to find some security issues since this wasn't homemade implementation. And then in 2017, I had my first very experience to assess an application that rely on Keycloak as an authorization service. Unlike the previous one, it was a bit difficult because the application used certified implementation, which make it very difficult to compromise and less obvious to detect security issues. And in 2019, I have decided to switch from working as a full-time penetration tester to application security engineer. And funny thing, one of the question I had in the interview, what is your experience with Keycloak? I said, yeah, I've done a bit, but in my mind, it was really painful. And now, I switched completely from as I said, from working as a penetration tester, and now I'm working with the good guys to make sure that bad guys won't break into our IDP and critical business application. And this is what I'm going to share with you today in this talk. We are going to walk through the common security issues that um, we can find in OAuth and specifically in Keycloak. Each issue will be demonstrated by real-world example breaches that did actually happen for some existing companies. Um, we'll try to talk about OAuth in general, and since this conference is about Keycloak, we'll try to see how these issues apply to Keycloak. And finally, we will try to have a quick overview on the future of OAuth and how it looks like from a security perspective to address all of these issues. A bit of background about myself. So my name is Abdessamad Temmar, application security engineer. I used to be a penetration tester. I'm certified ethical hacker since 2014 and member of the OWASP community. I had a chance to contribute to different projects. And as a side project, I built a platform called Keycloak Academy, which is an e-learning platform to teach people on how to use this solution to implement identity and access management. A brief introduction about OAuth and its security model. I won't go through the details on how this flow is executed, but here is the essence. In OAuth, we have 4 actors: an authorization server, an end user, a client, and a resource server. By the end of this flow, we will get a key. So OAuth is a delegation framework. As an end user, I delegate to a client application a kind of key to access my protected resources on the resource server. So this key is signed, so it's kind of stamped by the authorization server, and this way I can access as an application or a client application the user protected resources. And this key comes in the form of tokens, and in a specific format called JWT, GWT, JSON Web Tokens, and a client application can get up to 3 tokens: an ID token that represents the identity, an access token that represents the key or the authorization to access the protected resources, and both keys has lifetime. They will expire after a certain time. That's why we have a refresh token that can be used to extend the lifetime of these 2 tokens. Third question is where we can store these tokens once we obtain them as an application or as a client application, where we can store them. The first option, or the most common approach when it comes to browser-based application like Angular, React, etc., is to store them locally, either on the local storage or the system storage. But this is considered as a bad practice because it exposes these critical piece of information to attackers. And if we look today at the new wave of attacks that targeting users, especially in high secure organization, usually we can't manage as an attacker to compromise the credentials because we have 2FA, we have many security barriers that you need to go through. But now the focus has shifted to steal or compromise the user proof of authentication, which are the tokens. And we have noticed 2 possible ways to steal user tokens. First way is by exploiting cross-site scripting issues. This is still one of the most common issue we still see today in modern application. And this is demonstrated by the latest report from HackerOne. And an attacker can abuse or can exploit this issue by forging a payload, which is a piece of code that will be executed under the context of the user to exfiltrate or to extract the token from the local storage, send them back, and then exfiltrate them to a malicious server that he already owns. And from there, he can either do refresh token operation and also access the user protected resources. In order to demonstrate this, I have prepared a quick demo. So here I have 2 things. I have single page application where the user is already authenticated with Keycloak. And in the local storage, you can see that we have the access token and the refresh token. And on, yes, okay. But the idea here is that we have client application with 2 tokens stored in the local storage. Here is the access token and the refresh token. And on the side, I have a malicious server. I will show you just quickly the source code of this malicious server. So basically, we set up a continuous check to see if the client is still up. And then the attacker will use this malicious code to grab the token from the local storage and then send them to the remote server. And the remote server will continuously check if we got some tokens and wait until the client is offline, which means the user switch to another application in order to perform the refresh operation and take over the account. So this way, the user won't even notice that something fishy did happen while he was in the application. We'll go back to the application. So again, I have the clients and the malicious server. Let's suppose that I, as a user, as a victim user, I received a link to the same application, which will trigger the malicious code I just shown lately. And then once the user click on the link or visit the link, this will trigger the malicious code, which will send the refresh token to the malicious server, and then the malicious server will just wait until the client or the user switch to another application. So here, for example, I'm switching to another website, but on the server side, I've already extracted a token. And once we detect the client is not active anymore, from here, it's already done. And we have the access token and the refresh token. The refresh token is like permanent access to the user session. Second option to steal user token, and this is we have also noticed in the wild, is by using classic malware. And the perfect example for this is the info stealer, which targets Discord users. And actually, the source code of this malware has been disclosed and analyzed. And by checking the source code, we can see that um, here we just, as before, we extract the token, we save it to a local file, and then we use this exfiltration command to send the tokens to the remote server. So both scenarios are different, but in terms of results, it's the same. We are always after these tokens that represent the key to access the user protected resources. And this is the first sin, insecure token storage. And it's why do we need to care about it? Because simply when an attacker has access to a JSON Web token or a self-contained token, um, he can send it directly to the resource server, and the resource server will be able to validate it without any interaction with Keycloak, which means that once a token is leaked, we don't have direct control over this token, and it's extremely difficult to invalidate it. And this is even worse when you have misconfigured or permissive OAuth scopes that can be exploited to perform privilege escalation. One possible attack we notice in this particular case is what we call token upgrade. So usually an attacker will get an initial token, and this one might be not that powerful in terms of scopes and roles. And an attacker wants more. So he wants to abuse or access the other applications. So one possible way is to perform the token upgrade, where he would try to abuse the authorization service to get a new powerful token which has more resources, and then use it to access other protected resources. In the context of Keycloak, one possible way is to abuse the exchange token. We had a nice talk about this feature this morning. If we have a permissive policy for this feature, it can be abused to get or exchange the initial token to other tokens that can be used to access other resources. But there is a simple way, and here we are going to switch to the second sin, misconfigured OAuth scopes. We have a setting called full scope allowed. It's hidden somewhere in the client configuration, and it's enabled by default. And when it's enabled, the client application can request any scope from the list. Why this can be dangerous? Let's suppose that we have two client applications, Document Vault and Expensely, and a user who has two roles in both application. Here, as the first application, which is Document Vault, I can request, when I request an access token, not only I will get the roles of this user inside my application, but all the roles that the user has even on other application. And this is due to the scope roles, which is also available by default. So in this case, as an attacker, if I manage to compromise the document vault application, the first one, I can easily switch to the second app since I have everything, all the scopes included in the same token. Another interesting token is, scope is the offline access. And this one, again, is available by default. And according to the spec and the documentation, it allows a client application to obtain, it's a special type of refresh token, but it can be used by a client application even when the user is not present or has already logged out. And from an attacker perspective, this is really interesting and useful because as an attacker, I don't need to worry anymore about the user being logged out. I can use this access token to maintain my access and um, continue to access the protected resources. What's next? Again, an attacker will always try to propagate and compromise other applications. Another possible type of attack is what we call passive token, where the idea is to exploit the trust relationship between all the client application or the resource server under the same realm. And this is due to the lack of audience check or audience validation, which is our third sin. And the audience is just a claim that we can add to the access token in order to restrict where this token can be used. So it's very interesting from a security perspective. And when we don't have this claim, the risk is that once we have an access token, we can pass it to any application that doesn't implement this check. A perfect example or a real-world example of the impact of the lack of audience check is the video incidents. This online platform use the login as login with Facebook account, so it uses Facebook as an external IDP. So here, as you can see, it's the classic OAuth flow, but at the end, we will get um, an access token that represents, that can be used by video application to verify the identity of the user. The problem with this implementation is that video doesn't check the audience. So as a result, as an attacker, I can set up my own application and if I manage to, and also enable the login with Facebook feature, and if I manage or receive the users to log in into my application, this will allow me to get access tokens that represent these users. And then I can simply pass these tokens to the video application, and they will be accepted because there is no audience check. Of course, the application will verify if the token is signed by Facebook and contains the necessary claims, but it doesn't check if this token is intended to be used in the context of this application. And this, an example of using this token, we can pass it directly to the application, and then we will get a new access token to identify as the new user that we have represented by this Facebook access token. So it's very important to implement the audience check. Now I'm going to switch to different type of risks where the problems can come from the integration with external identity providers. And a perfect example for this is the login with Microsoft through Azure. It's an issue called the no-auth, and it impacts all the application that use sign in with Microsoft. In order to understand this issue, I'm just going to start with a brief reminder of how identity brokering work in Keycloak. So this feature allows Keycloak to delegate authentication to an external identity provider. So basically, when the user is redirected to Keycloak, we can give him the option to authenticate with other external identity provider, which is step one. And then in step two, we'll get the token in the external formats. And this should be mapped to the internal format of Keycloak. And this is done using identity provider mappers. And the idea is to, even if we have naming convention that is different from what we know, using this feature, we can map it to our internal representation. So for example, I can map the email address as a username, etc., etc. In order to exploit the no-OAuth vulnerability, there is two prerequisites. First one is, as identity provider, I need to trust the email claim and use it directly as a username or for user verification, and automatically merge the accounts with if the user already exists in the IDP. In case of Keycloak, the first requirement is somehow already possible, because if you look at the source code of the Microsoft identity provider, you can see that we directly extract the mail claim from the token and use it as a username. But that it's not enough. The second requirement to exploit this is to enable a feature called automatically link first login flow. And this one allow you to, once we detect a user that we already know by his, by example, his username or email address, to merge it automatically with the existing one. And this is something that I found a lot of people asking on how to implement it, so it's perfectly possible to came across this setting in production environments. And let's see what happened when we satisfy both requirements. So here I have first my local Keycloak instance, which point to Microsoft as an external identity provider. And as an attacker, in order to exploit the no-OAuth in case of Keycloak, I just need to create an Azure account. Okay. Sorry. Thank you for letting me know. So here again, I have my local instance, which point to Microsoft's Azure as an external identity provider. And then as an attacker, what I need to do is to create a new tenant in Azure. You can create one for free if you want to. And then how we can exploit this in the case of Keycloak. So first thing I'm gonna show, in this instance, we have I have created a user called tests with this email address. I can test the login with this user using the accounts cancel. So it's tests. And the goal as an attacker is to compromise this account without knowing his password. So I'm going to log out. And if I go back to my tenants, I just need to create a new user. And then under properties, confirmation, contact information, sorry, it's in French. I just need to put the same email address that the user is, that was configured for this user. Let's try again to log in with this user, but using the Microsoft's Azure tenant. So here I just need to click on login with Microsoft, copy the username, and here I'm going to use the password I have for this user. And bam, I have access to the user account without knowing his password. And this is how we can exploit the no OAuth vulnerability. Um, Next, so we need to be, and this is the fourth thing, binding identities with mutable attributes. Attribute that can be changed, that can be modified on the external identity provider. And this is really important because identity theft is not a joke. Next, the last one, but not least, is using outdated protocols and libraries. At the beginning, I mentioned how one of my very first experience was to assess an application using OAuth implicit flow. Unfortunately, it's still the case even for new applications. So we still see implementation that uses this type of protocol. And from an attacker perspective, it's very easy to compromise compared to the latest version of OAuth. And this is a summary of the five attacks that uh, um, we have. So, and if I want to represent the five attacks in one single attack chain, um, as a malicious or as an attacker, the starting point will be to exploit a cross-site scripting vulnerability inside this application, extract the user token, and from there, either use a token upgrade attack or pass the token technique to um, escalate or access other API or other protected resources. And the second option is just to set up a malicious identity provider in case Keycloak is using the login with Microsoft feature. Now, how the future looks like for OAuth, how we can um, mitigate these type of risks. And the first thing is we are now switching slowly to the OAuth 2.1. It's a new draft for this authorization framework. It's still in draft mode, but likely for us, Keycloak is already compliant with this new spec. And the main change on this spec is we are finally getting rid of all deprecated and outdated authentication flow like the implicit grants. And this will definitely reduce or eliminate the risk of using deprecated grants. And then we have another interesting feature called demonstration of proof of possession. This is a security mechanism that add sender constraints in order to validate the owner of an access token before processing it. And this is can definitely reduce the risk of pass the token attack because as a resource server, I won't accept blindly any token I receive from the client application and add a second validation. And there is another spec that it's still also under draft mode, which is more specific to browser-based application. And for the first time, we are mentioning directly or explicitly the risk of tokens exfiltration using malicious JavaScript code like the one we saw at the demo. And the recommendation is just not to store these tokens at all in the local storage, but to switch to the backend for front-end patterns or the BFF. The BFF is simply we will add a backend that acts as proxy, and it will manage the whole OAuth flow. And then when the user is authenticated, we can securely store these tokens on the backend side, so the attackers don't have direct access to these tokens. And for the single app, we just provide a simple cookie. This is really interesting from a security perspective because not only we will make sure that our tokens are protected, but even when we detect something fishy, we can invalidate these tokens directly by since we know where they are stored. And this also will mitigate the first type of attack, which is token exfiltration. Some important takes before I finish my talk is avoid browser token storage and switch to BFF patterns in case you are using a single page application. Avoid permissive scopes and use token exchange feature to implement fine-grained um, or least privilege authorization scheme, and also enable and use the proof of possession. Likely for us, it's already supported by Keycloak, so we need to take profit of this security feature. And when it comes to identity mapping, we need to make sure that the claims that we are using cannot be changed down the road. And also we have security profiles, which is a really nice feature in Keycloak. It allows you to enforce all these security best practices by default when you create a new client. So this way we make sure that our clients' application are secure by default. So that's all on my side. Again, my name is Abdessamad Temmar, and I'm looking forward to your questions. Sorry? Was it?
Yeah, thanks for this talk. You're the second one telling me today to disable full scope. Why is it default activated? Or should we change it?
I, I, um, I don't know. I can't answer this question, but as someone who work on the security team, I will say, yeah, we need to disable it. But yeah, we need to study the impact of uh, having this change because it will definitely cause some break some stuff in case we enable this in future versions. So I agree we need to enable it or disable it by default, but we need to study the impacts. It's like what happened with the info user install introspection. In the past, it was possible to consume this endpoint without directly, but at some version, you need to have the OpenID scope. And this, I can check on the internet. I saw a lot of people asking how to enable it or how to fix this issue. So yeah, again, it's really important, but we need to manage this change carefully.
Hello, my name is Lars. Thanks a lot for the talk. It was very, very interesting. What would you recommend as staying up to date, or how would you define best practices? How to get informed about these issues that you just mentioned, the best practices when new things come up, when there are news? What would you recommend to stay up to date? Some places, some. Will you give this talk next year again on this conference, for example, or?
Yes, maybe I would love to. Yeah, that's a nice question. It's especially when you are working as a developer, it's not really directly your responsibility to be aware of all these common risks. But personally, I try to subscribe to some mailing list or newsletter where I can share later on some example where you get each two twice a month contents, summarized content that you can read in 10 minutes. And inside there is dedicated section to application security. And OAuth is one of the most common topics that comes to inside this section. So yeah, so following or subscribing to newsletters and maybe following cybersecurity folks on Twitter and so on. And also good one, the OWASP community. It's a quite big community. You can check on the resources. It's all for free. And actually, in the application security verification standard, which is a document that contains the requirement to implement secure application, now you have a dedicated section to OAuth, and it mentions basically all the things that we have discussed today.
Thanks a lot.
Thanks for the interesting talk. Can you recommend any penetration testing tools with focus on Keycloak? I'm thinking about OWASP tab scanner or something similar. Are there any tools that can just scan my Keycloak and look for vulnerabilities?
Yeah, that's another interesting question. Um, I think the most of these issues can be detected using by reviewing the configuration of the Keycloak clients. One nice approach I saw publicly is using open policy agents with some policies to validate the JSON files. And detection is not the only answer. As I mentioned before, there is the security profile that we can enable. And this way, we don't have to worry about having these kind of issues in our Keycloak.
Thank you for the talk. I was very interested in the backend for frontend flow that you explained. Unfortunately, I don't have control over the applications that are clients that use my Keycloak. Is there any way I can enforce that the client applications have to use this backend for frontend flow by configuration? Or is there no way to enforce it for me as the owner of the Keycloak, but not of the client application?
Uh, Actually, if I go back to the PDF, this, from what I understand, you call directly from the single page application, the remote API. Is that correct?
I'm sorry, I did not really understand what you mean.
Um, your current implementation is that you, from the single page application, you have the tokens and then you call the remote API.
Um, no, what I am worried about is I only control the authorization server, but different teams or different customers control the applications that authenticate with my server. Is there any way in my configuration that I can enforce that makes it impossible for them to store the token in the front end and that force them to use this pattern?
So you don't have control over the single app or single page application. In this case, it's complicated. Again, it's change in terms of architecture and it involves both parties. So unless there is a commitment to apply the change on both, I'm not aware there is any tweak to enable it in one side and uh, have it or keep the current architecture without any major change.
Thank you.
Thanks for the interesting presentation. I want to ask some question that is related how maybe Keycloak is used in the community, and I want to ask your opinion. First of all, Keycloak allow uh, re- to have refresh token for every flow for client. Do you believe that is this correct? For us, we don't enable for any client to have this functionality because we believe it's insecure, as mentioned in a way to in some slide that you have. However, if offline scope is different because you don't have a browser. And the second one is related to upgrade scope. The only way that I know is with some people want to upgrade to add scope in with token exchange. A token exchange protocol is rather not specific about it. However, we believe that this is very dangerous, and there is a discussion in Keycloak about token exchange in order to be official support. If this must be supported, what is your opinion? Uh, for this feature of token exchange. I don't know if there is any progress in Auth 2.1 for token exchange.
Personally, I don't think the problem is related, or the security issues is related to token exchange as a feature, is just the way we implement it.
I say about upgrading scope for token exchange. In this feature, not token exchange. We use token exchange very much.
I'm not sure if I understand the question. Sorry.
There is a discussion in token exchange with scope parameter. If you could add additional scope in the original scope, in the original
Okay.
access token. So someone have a request client scope, for example, file, and somewhere else with token exchange could add email, arc scope.
Okay.
This is my question, not for token exchange.
So if I understand correctly, with there it's a good thing to upgrade the scopes inside the resulting token after the exchange.
Yes.
Um, it depend on the context of the the application, but for the spec, usually we don't recommend passing the scopes in this type of operation. And the reason behind is to avoid um, the top upgrade attack, as I mentioned. So yeah, it's I think it will involve some security risks in case we implement or enable passing the scope during the exchange feature or operation. I'm not sure if this answers the question, but we can have
my question.
but we can have discussion afterwards if you.
I agree with you. Thank you.
Thank you.
Okay, are there any other questions?
There was a question.
Oh yeah, great.
There you go. So in the case of cross-site scripting, if if you're worried about someone pulling from local storage or session storage, usually they can only do that if it's on the same domain. So it's your concern is someone has injected malicious code to your site through maybe a library or something similar. Is that the concern? And then could you not mitigate some of this through configuring your backend with cores appropriately to have the browser handle that?
So if I understand correctly, asking about a way to mitigate the risk from a configuration perspective, or
So you're talking about cross-site scripting and pulling data from local storage to session storage. My understanding, and maybe it's wrong, is you can only do that from the domain upon which it was stored from. And so if that's the case, you would have to introduce malicious code to that site in some manner, right? And
yeah,
that's usually through like a library or something else that you weren't aware of. If you also have cores configured correctly, like you're serving course headers correctly, someone should not be able from that browser to make additional requests to somewhere else, right? So is that a way to mitigate that concern in a way that kind of fulfills the security posture?
Yeah, that's a good question. Actually, the malicious code has will use the same technique as a legitimate app to extract the tokens. So since it's running under the context of the vulnerable application, I can have access to, I have the same permission as this application. And then regarding course, the course policy is, as an attacker, I own the server, so I can put store on the source, and this way it won't be blocked by the browser since my course policy is permissive, and I can even if the target domain doesn't match the actual domain, it will be possible to exfiltrate the token. I don't know if this answered the question, but we can have a discussion later on if you want to. Thanks.
Okay, are there more questions?
Otherwise, I think we'll wrap it up here. Thank you for the talk and have a nice break.